Hi, Math 11. So I got a few questions to go over. I'd like to go over these, and then I'll get you to do um, the unit test for this final unit. So I went over the schedule with you um, last class. Um, so again, I'll give you a review tonight. I'll just put the schedule back up here. So again, I'll give you the absolute value test for tonight's class, and then Tuesday we'll have review. So I'll kind of give you an idea what the final exam will look like, and then on the 28th we'll have the final exam. Okay. Some of you are asking how long will you have to complete the final exam. I'll give you about a week to finish that. Okay. And so keep sending questions, any questions that you may have. Like I said, I did update the marks. Some of you have contacted me to find out what your percentage is. So if you still want to know that, just let me know. Okay, so let's go over a few of these questions here. So here's 6A. So here's the question. They give you this line. So that's your original function. And so what we can do here is we want to graph the reciprocal function. Okay, and so what we want to do is and they ask us about intercepts and invariant points and all that. So let's start with invariant points. So an invariant point is a point that's going to exist for both the regular function and the reciprocal function. So that means both functions will share these points, and they always occur. So this is having to do with regular functions and reciprocal functions. They always occur at y equals 1 and y equals -1. So if you can find the coordinates from one of them, then you know it for both of them. So here here's y equals 1, so you've got the coordinate 2, 1. Okay, and then here's the other one, 1 and -1. Okay, so again, it's always at -1 and +1 for y. So that's your invariant point. So again, invariant points are values that will exist for both. Now, the other thing that we can see here is the y-intercept is -3. The x-intercept is 1.5. The x-intercept is important for the regular function because that represents where the normal function is equal to 0. Okay, that's what the x-intercept represents. Okay, so that's now for the reciprocal. Remember, the reciprocal is going to be 1 over whatever this function is, and if the bottom is 0, it doesn't exist. So this is always going to correspond to the asymptote. Okay, for the reciprocal. So what you have here is you've got an asymptote that's going to be right here. Okay, now the reciprocal function. So like let's say it's let's just say it's y equals 1 over fx. Okay, because you don't have any variables up here, there's no way this can become 0. Okay, and so this is your vertical asymptote, and then this is your horizontal asymptote as a result of this not being able to equal to 0. So now what happens is your reciprocal can't touch either of these lines. So and you're going to have two branches. So here what happens is here's one branch, and see how it touches the the invariant point, and then here's the second one, and same thing, it's going to touch that invariant point. Okay, so the invariant points are values both the regular function and the reciprocal function share. Okay, so this is the regular function, and this is the reciprocal function. Okay, let's look at another one. Okay, so this one here, I think this one was a typo in the textbook. Like if you look at the back of the book, the answers, I think they said x minus 4, but it's x minus 16. That's the way the question is framed. So this time we want to graph both the regular function and the reciprocal function. So remember, this is linear. So this is again, this is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so here your y-intercept is negative 16. Okay, and then what happens here is there's nothing in front of the x, which means the slope is 1. So that means you go up 1 across 1, up 1 across 1. So if you follow that all the way through, you're going to end up at 16 here. So this would be your x-intercept. So if y is 0, then x has to be 16. Okay, so this is your x-intercept. Okay, so here's your regular function. Okay, and so again, same as the one we did above. Your x-intercept is 16. That's where this becomes 0, and your reciprocal, right? So your reciprocal function is going to be equal to 1 over x minus 16, right? And so if 16 causes that to be 0, it's going to cause this to be 0 as well, and 1 divided by 0 is invalid, right? So that's why this becomes an asymptote. Okay, so that means you can't go there. And then again, there's no way this can become 0. So this is a horizontal asymptote. Okay, and then same as before. This is called this positive 1 and this one negative 1, right? So like if y equals positive 1, that means x has to be equal to 17, right? So let's just say let's call this 17 here. Okay, and then if x equals negative 1, that means this has to be 15. So let's just call this 15 over here, right? So these are your two invariant points, and so same as before. There's one, and there's the other. Okay, and just like before, just like the one on the top there, because you don't cross the x-axis, that means the reciprocal does not have an x-intercept. Okay, so the reciprocal doesn't have an x-intercept. It will have a y-intercept, right? So if I wanted to find the y-intercept, I'd just make x equal to 0. And so the y-intercept of this would be 1 over negative 16. So I mean, you can't really draw that, but that's what it would be. Okay. Okay, let's look at the next one here. So we've got 2x plus 4. Okay, so again, your slope here is 2. Your y-intercept is 4. Okay, so that's why you're here at 4. Your x-intercept is if y is 0, so that means x would be negative 2. Okay, so we can draw a line here. Okay, and so if this is your x-intercept, again, this is your vertical asymptote at negative 2. Okay, and then your horizontal asymptote here. And then you would have your invariant points. So if y equals 1, that means that x would have to be negative 1.5, right? So like somewhere around here, right? There would be an invariant point. And then if this is equal to negative 1, then that would make this be negative 2.5, right? So somewhere around here. Okay, so negative 2.5. And so here's your, right, and this keeps going. And it keeps getting closer to the asymptote, but never touches it. Okay, so those were the ones where you're looking at linear equations that have turned into reciprocal functions. The other kind is a quadratic. Okay, so here we got x squared minus 2x minus 8. So we can factor that. We get x plus 2, x minus 4. So your x-intercepts are x equal to negative 2 and 4. And then your y-intercept here is going to be negative 8. So you can get that right from standard form. And then you can use the vertex formula, which I think was negative b over negative b over 2a to get your x, and then you solve for the y. So it works out that your vertex is going to be 1, negative 9. Okay, so here's your regular function. Okay, so this is fx. Okay, so again, you got two x-intercepts and you have the one y-intercept at negative 8. So same as before. Anywhere you cross the x-axis, your x-intercept, that makes the whole function here equal to 0. And so again, the reciprocal is going to be 1 over x squared minus 2x minus 8. So if it causes this to be 0, the bottom part, then the whole function is invalid. So here's your, this time you're going to have two asymptotes, vertical asymptotes, and then the same thing, you can never make it y equal to 0, so you have your horizontal going this way. Okay, and so what happens is you'll have your invariant point at 1 and at negative 1. Okay, and so you'll have more invariant points this time. So at 1 you'll have an invariant point over here and an invariant point over here. Okay. Now how do we figure out what those invariant points are? Well, what you can do is you can make this equal to 1. Okay, so let's do that right now. Let's find one of the invariant points. So you go 1 equal to x squared minus 2x minus 8. So that gives you x squared minus 2x minus 9 equals 0. So what happens is you can't factor this. Okay, so what you have to do is you have to use the quadratic formula. So remember A, B, and C. And so what you'll find is you'll get two answers that are that contain radicals, and that'll be where the invariant, the two invariant points on the positive side are. Okay, I mean positive relative to the horizontal axis. So one on this side and one on this side. This one will be negative, this will be positive. And then you have to do the same thing for negative 1. Instead of making this equal to 1, you make that to negative 1. Okay, so you'll have a bunch of invariant points. So these are two branches, and then the third branch will be the one that kind of looks like this. Okay, and the same thing, there'll be an invariant point for, well, I don't know if there actually will be an invariant point here, negative 1 and positive 1. There might not be one here. Okay, and then you'll have a intercept here, y-intercept, where x is equal to 0. So this will be this y-intercept will be 1 over negative 8. Okay, that's what this will be right here. Right, because you make x equal to 0, and that's where you're going to cross the y-axis. Okay, and the last one here. So here, this one, 9c, they gave you the function, and they basically want you to draw the invariant, draw the reciprocal function. So they didn't tell you what the equation is to this. But what you can see here is you can see that you're crossing in at negative 1 and 2. So right away we can draw vertical asymptotes here. And then the same thing, we have a horizontal asymptote here. And so you're going to have, again, the same thing as before. And like I said last class, don't worry about being accurate with the reciprocal function graphs. They're a little bit hard to graph, and that's why as long as you know where the asymptotes are, that's good, because you basically kind of just following those. Okay, so this is definitely not precise, but again, it's a good rough sketch. Okay, so hopefully that helps. Send me some more questions if something doesn't make any sense. So I'll get you to do the take-home exam. Okay, so try to get that done as soon as you can. And then, like I said, Tuesday night I'll give you the review. And then Thursday night I'll give you the final exam. Okay, so we're almost there, just about another week and a half. So those of you who've been keeping along, way to go. Okay, keep at it. Those of you who haven't, I mean, you still have an opportunity to kind of get back in the swing of things. And just send me a message if you have any questions. All right, so I'll stop there. Look after yourself, be safe, and I'll talk to you again on Tuesday. Okay, bye now.